The Edge stick modules, as they come from Sony, can't be calibrated in the Edge controller. In this video, I'm going to go over a few modification options to fix that. I'll give a bit of detail about some of the small SMD parts around the memory chip, the parts that are at risk of being damaged or lost when modifying the module, and I will give some detail about the memory chip itself. Let me start with the memory chip, as it is at the heart of what we're trying to do. This is a view of the bottom of the stick module circuit board, and this is the memory chip. It's an ST Micro M95040-D 4K-bit SPI bus EEPROM. I'm sure of that because this is an M95040-DFM-C6 ST Micro memory chip, and other than the code date, they are the same IC. Here's a schematic diagram I drew up of the memory chip circuit. Let me turn your attention to pin 3, the write protect pin of the memory chip. It is a logic level input and has two states, high and low. When pin 3 is pulled low, the memory chip is write protected, meaning the data in the memory chip cannot be altered, and therefore the calibration data cannot be saved. This 4.7 k ohm resistor here is responsible for pulling the pin low. The main focus of this video will be on the ways to pull the write protect pin to a high level, and therefore allowing the data in the memory chip to be altered. So let me define low and high a bit better. In the Edge controller, this memory chip's VCC supply voltage is 1.8 volts. So a logic low input will be any voltage below 0.45 volts, and a logic high will be any voltage above 1.35 volts. Before I leave the schematic, let me point out two other parts. There is this very small capacitor here. I measured it at a little under 150 picofarad. And there is this 2.2 k ohm resistor connected to pin 1 of the memory chip, the chip select line. The 2.2K, the 4.7K, and the 150 picofarad parts are very close together on the circuit board. And while the controller will work just fine with the 150 picofarad capacitor missing, it will not work with the 2.2 k ohm resistor missing. Back to the board view, and I'll zoom in on the memory chip area. This is pin 1 of the memory chip, and this is the 2.2 k ohm resistor that connects pin 1 to 1.8 volts. Right here is the 150 picofarad capacitor, and right next to it is the 4.7 k ohm pull-down resistor. As you can see, there are open pads in between. This pad right here connects to pin 3, the write protect pin, and the pad right across from it goes to the 1.8 volt line. These are going to be important for a couple of the modification options. This pad connects to pin 2, the data output line of the memory chip. We don't want anything connected to it, and the pad across from it is connected to ground. I'll zoom out a bit. This test point here is accessible when the memory stick module is completely assembled, and it connects to the write protect pin. This is how Sony enables writing to the memory chip to calibrate the module. When this test point is connected to the 1.8 volt line, the memory is writable. And there is this test point here. This is the 1.8 volt line. And again, these two test points will be important when I get to the modifications. I'll go over the 3 final parts around the memory chip, though I wouldn't expect there to be any need to ever have to touch them. This capacitor here is a 100 nanofarad bypass capacitor. This resistor across pins 7 and 8 is a 0 ohm jumper, and this large resistor here connects to the clock pin of the memory chip. Its value measures 100 k ohm. So now it's time to see how to get a high level on pin 3 of the memory chip. I'll call this the Pro mod, as you will need equipment to deal with 0201 size SMD parts. They are very small. In fact, their size is approximately 0.6 millimeters in length and 0.3 millimeters in width. If you're accustomed to replacing 0201 SMD components, then this is what I feel is the best modification option, the Pro option. First up is to remove the 4.7 k ohm resistor connecting pin 3 to ground, and hopefully not destroying the 150 picofarad capacitor next to it. I'll put a bit of flux on the resistor. It does appear that some of the SMD parts on this side of the circuit board may be attached with some adhesive. So I'm going to put my tweezers on the one side of the resistor and apply just the smallest amount of pressure. The iron temperature is set to 740 degrees, so close to 400 C. I don't think I have quite enough solder on the tip, but at some point it will let go. There we go. The tweezers have a pretty sharp tip on them. It would really be best if the tips are a bit blunt, as I did scrape the solder mask. I'll put some fresh tin lead solder on, and then remove the excess with some solder wick. Then clean the flux off with some isopropyl alcohol. Looks good other than the small scrape on the solder mask. Didn't rip up either pad, and the capacitor is still there, so I'll call that a success. Now this has been the position of the 4.7K resistor in every stick module I've looked at, but the fact that the 150 picofarad and the 4.7K resistor are in parallel, it's probably a good idea to check the resistance from pin 3 to ground. It should be in the mega ohms plus range. If it still reads around 4.7K ohms, then that would mean the capacitor and resistor positions are swapped. But it's open, so I got the right part. The solder on the pads is a lead-free solder that really doesn't flow very well. So I'm going to put some flux down and coat the pads with some 6337 tin lead solder. I'll use a bit of solder wick to remove the excess from the pads. Clean it a bit. They look good and flat, and that is what I'm looking for. I'm using some tin lead solder paste here, and a pick with a pretty fine point on it to apply the paste. Maybe a bit much, but it is hard by hand to get just the right amount. This is an 0201 4.7K ohm resistor. I feel almost any value here less than 10K would be fine. The next challenge for me is getting the resistor in position. If you have good steady hands, this will be much easier. Bit of poking and prodding, I'll get it into position. I have the hot air at 800 degrees and 4% airflow. I'll heat up the board a bit, but not much, as I don't want to melt any plastic on the joystick. Now this tin lead solder paste will melt long before any of the other solder on the board. There we go. That looks pretty good. It was a little too much solder paste, but this is, I would say, the fourth 0201 part I have replaced, so it's not something I do very often. Again, if you have the proper equipment, I feel this is the best way to enable writing to the memory chip. The circuit board is made for it. I'll call this the no solder mod. The first thing I'll do is scrape over these solder pads. I want to remove any flux or oxidation on the solder. I can see I'm actually scraping into the solder on the pad, so that should work well. I'll clean it a bit with some isopropyl alcohol. I want to remove any loose flakes of anything. I'm going to use a sewing needle as an applicator. I need a very fine point for this. I'm just dabbing a bit of the conductive paint across the two pads. And that looks good. It will have to dry, and then I can check its resistance. What I'm using is K-Coat 44. I'll put a link in the description. It's not cheap stuff, but I've used different items from Keg Labs before, and I've always been very happy with their products. There is a 4.7 k ohm resistor from the write protect pin to ground, and I need 1.35 volts or more on the pin. If everything is perfect, any resistance below 1500 ohms will work, but cutting it close is always a recipe for disaster, so I'm looking for a resistance much lower than 1500 ohms. It's been a little over an hour, so I thought I would check it. It's more like a small blob of the paint than a thin coat, so it will probably take a bit longer to fully dry. Wow, much lower than I expected. Only reading 3 ohms. Well, that will get the job done. It is pretty dry. Won't stick to the tip. Only makes a small mark on it when I touch it with the probe. That did better than I was expecting. So if all you have is a soldering iron with the large tip you use to replace the joystick, this is a good option. There is another option using the conductive paint. I'm not a fan of using it this way. First, the solder mask from the write protect test point to the 1.8 test point has to be in perfect shape. No pinholes or scrapes. I'll scrape the test points to make sure I get good contact. And I will clean the board where the paint is going to go. I'm going to use one of the applicators that came with the paint. A tiny paintbrush would probably do a bit better. This conductive paint is going over ground and a trace to the TPM chip, and if there is any defect in the solder mask, this method will fail. I'll remove that extra paint that's spread over the joystick traces, and I'll let it dry. After drying a couple of hours, I'm at less than 200 ohms, so this will work. But putting the paint across the 0201 pads like I did at the start of this section, I consider a good option, and I don't consider this a good option. The big concern is going to be where the bottom cover plate will rest on the circuit board. It will rub. So the rubbing might flake off the paint, and any flakes could work their way into the circuit and short out. I wouldn't expect any lasting damage, but the controller would stop working until the short is removed. I'm not going to recommend this approach. 99 out of 100, this will probably be just fine. But if you want to use conductive paint, I would stick to putting it across the SMD pads. Nothing can rub on it there, so it should hold up very well. I'll call this the Force Pull-Up mod. It's much like the first part of the No Solder mod, except with solder. I have the soldering iron temperature at 700 degrees, about 375 C, and that might be a bit on the hot side. Now this is the smallest iron tip I have, and I'm using some 6337 tin lead solder. The idea is to bridge solder across the 2 pads, and only those 2 pads. That looks good. If the solder doesn't want to bridge, try turning down the iron temperature a little bit. The 4.7 k ohm pull-down resistor here can stay or be removed. Removing it will save about 700 microwatts of power. Really the only reason to go through the effort to remove the pull-down resistor. But if you have the soldering skills to bridge the 2 pads, you have the skill to remove the pull-down resistor. It is possible this resistor is held down with adhesive, so it may take a little bit of force to remove it. Just make sure the solder is melted before applying pressure. As with the removal of any part, there is always the possibility of board damage. I'll put some flux on it and clean up all that no-lead solder sticking everywhere. Remove the excess with some wick and clean the board with some isopropyl alcohol. Looks better than new. This one, I could not get the solder to bridge just the 2 pads it needed to. I tried quite a few times, so I used a very small wire to make a jumper across the pads, and then very lightly cut the extra wire off. And you have the option of removing the 4.7k ohm pull-down resistor to save a bit of power. Of course, the best way to jumper the pads is to use a 0 ohm resistor. That will require putting down some solder paste. Looks like I overdid it with the paste. And then putting an 0201 0 ohm jumper in position on the pads and solder paste. Using the 0 ohm jumper instead of a 4.7k ohm resistor like in the Pro Mod section allows you to leave the 4.7k ohm pull-down resistor in the circuit. The hot air gun is set to 800 degrees and 4% airflow. And this is a tin lead solder paste, so it will melt before the OEM solder on the board. And there we go. That looks good. It can be put back together and then calibrated. It's ready to go. These 0201 resistors can be soldered without using solder paste and a hot air station. You will need a very fine tip on your soldering iron and a lot steadier hand than I have. I've cleaned the solder off the pads with some solder wick, and then I will add as small amount of solder as I can to only one of the pads. Then I will put some flux on the pads. Now the hard part for me, holding the resistor in position and melting the solder on the one pad while kind of sliding the resistor into the molten solder. I didn't quite get the resistor flat on the board, so before I solder the second terminal, I'll press down on the resistor while melting the solder on the one terminal. Then I will solder the second terminal. I'll put some fresh flux on and make the solder joints look pretty. Always a good idea to check the resistance between pin 3 and the 1.8 volt pad. And good, everything's soldered like it should be. With the 0 ohm jumper and the 4.7k ohm pull down resistor in circuit, resistance from pin 3 to the 1.8 volt test point should read very close to 0, and the resistance from pin 3 to ground will read less than 4.7k ohms. I'll call this the point-to-point mod. Until now, I've been dealing with the very small contacts and components right around the memory chip. Now the object is to electrically connect these two test points. Soldering-wise, this is much easier, there is no doubt about that. But there is a complication that the plastic base plate is flush with the bottom of the circuit board, from the top of the alignment holes to the edge of the 14-pin connector, this area here. So anything run in this area will cause a gap between the board and the base plate. I'm going to put some fresh solder on the test points and then clean them off with some solder wick. Then I will remove the flux with some isopropyl alcohol, as well as clean the area from the right protect test point to the 1.8 volt test point. I'm putting some Kapton tape on the board from the right protect test point to the 1.8 volt test point. Even though the thin wire will have an enamel coating and the solder mask is in good shape, the plastic base will put pressure on the wire and could cause a short to ground over time. The area where I'm placing the short piece of tape has plenty of space, and nothing will rub on the wire. I'm using some 34 gauge enamel coated copper wire. If I had smaller wire, I would use it. This is about the largest I would want to use. The solder contact to the right protect test point needs to be as flat as possible. I'll shape the wire into the position I want, and then cut it off somewhere close to the midpoint of the 1.8 volt test point. The solder connection at this pad doesn't need to be flat, just needs to be a good connection. Then I will put a piece of tape over the wire to hold it in place. As you can see, the wire does cause a gap between the plastic base and the bottom of the circuit board. With the 34 gauge wire, there is a gap in the base plate. Some have cut away the plastic where the wire goes, but I'm not really a fan of cutting the plastic. The plastic base has a channel in it that is used to align the module in the controller, so I don't really like the idea of weakening the plastic. And I haven't seen any problems with a small gap like this, but like I said, I wouldn't use any wire larger than 34 gauge, and smaller would be much better. Now, what I like better than wire is to use some very thin copper tape. And you can probably get a small roll of copper tape cheaper than a small spool of 40 or 44 gauge magnet wire, at least from Amazon. You do want to make sure it is a metal foil tape. Then you can cut a thin strip to run from test point to test point. It ends up being flatter than the wire, and I feel it is a bit easier to use than, say, 40 or 44 gauge wire. It's easier to see at least. So those are my modification options, the first one being my most favorite and the last one being my least favorite. Of course, the last has the big advantage of not really requiring any special soldering equipment, so I would expect it to be the most used mod. Just keep in mind, flatness, flatness, flatness when you use it, and it should work fine. Now, many have asked, does it need to be removed after the joystick is calibrated? And the answer is no. Once you pull the module back apart to remove the jumper, the chance of the circuit board locating back into the same position is not great. So while centering will stay the same, it will shift the circularity some. So really, anytime it's pulled apart, it might need to have the range calibrated again. If you have used one of the modifications that leaves the 4.7 k ohm pull-down resistor in place and you are worried about the extra power draw, don't. It's a very small amount. And if you change the joysticks in the module to a TMR joystick, even with the pull-down resistor in place, you are still pulling less power now than with the original joystick. If you're doing one of the mods that changes the 0201 devices, then I would do the mod before replacing the joystick. But if you're using the point-to-point mod, then that really needs to wait till after the joystick is replaced, as you are going to be running wire or copper tape near the joystick switch terminals. I've given a bit of thought to which mod is the least likely to cause unintended problems, and I do believe that would be the no solder mod, and leaving the 4.7 k ohm pull-down resistor in place. There is really very little that could go wrong. If after modifying the stick module all you get is the controller flashing the LEDs, then the controller is not getting the information it's expecting from the module. Look for solder bridging, especially around the small SMD components. Make sure the 2.2 k ohm resistor to pin 1 of the memory chip is still in place. If you have a multimeter, make sure the 1.8 volt line is not shorted to ground. Most likely there is going to be solder where it shouldn't be, so look very close, as the pitch of the pins on the memory chip and TPM chip are very fine. Getting into the stick module is pretty straightforward. There are 3 small Phillips screws on the bottom of the stick module. I would say a 00 Phillips would fit. So removing the 3 screws is the first step. Now the module does have what I would call a tamper indicator. It's a plastic tab on the top of the housing that sticks through a plastic slot on the base of the housing. And the plastic tab is melted flat so it can't be pulled back through the slot. A sharp craft knife can easily deal with the tab as it's pretty thin plastic. Once the tab is cut off, the bottom housing can be removed. And now the only thing holding the circuit board in is the joystick shaft. Can pull it from the knob and then work on the board. I'm sure I've overlooked some options, but these are the ones I have tried, so I know they work. Leave any comments or questions you have, and subscribing would be great. I'll leave it here with a schematic diagram I drew up of the stick module. Thank you for watching.